Part 2, Geometry. Let's look at the problem. First problem, number 9. The side ABCD is a square that's 6 centimeters. Triangle AFD is part of the square. The area of CFE is 6 centimeters square greater than the area of AFD. Okay, if that's the case, that means this part adding to this part, not including this part, is 6 centimeter square greater than the area of the square, right? If we replace this triangle with this one, this is bigger than that by 6 centimeters square. So, okay, so the area of the square is 36, and this one is 6 centimeters square greater than this, and that's the area of this whole triangle. This whole triangle, the area is 1/2 multiply the base, that is AB, multiply the height, that is BE. AB equals to 6. Now we can find out BE equals to, this is 42, and this is 3. 42 divided by 3, that's 14. So BE is total is 14. BC, as you know, this is square, that's 6. So you can find out the CE is actually 8 cm. Problem number 10. ABCD is a rectangle. AB is 12, AD is 15. We divide this into 4 small triangle, S1, 2, 3, and 4. And area S1, S2, and this all equal. So this is 1/3, this is 1/3, and this is 1/3. So you know the area of this triangle and this triangle. You can find out the length of this part and the length of this part, right? For example, S1 equals to 1/2 multiply 15, that is AD, multiply the other side, the height. So let's call this one E, DE. So S1 is actually 1/3 of the total. 1/3 of the total is 1/3 multiply 12 multiply 15. So you can find out DE, right? Do the same for this one. 1/2 AB multiply, let's call this one Q, BQ equals to 1/3, that's 4 multiply 15, that's 60. You know AB is 12. Now you can find out BQ. You know BQ, you know DE, and you use 15 to subtract BQ, you get this side. You use 12 subtract DE to get this side. And then S4 equals to 1/2 CE multiply CQ. So we'll leave for the students to solve this problem. Practice problem 11. The area of a regular octagon is 40. Find the area of the shaded part. The shaded part is in the middle. So for this problem, we need to draw some lines to help you visualize. So you have this line, then we just need to divide the octagon into smaller parts. So we have S1, S2, for example, S3, S4, and inside there are 4, 5, 6, 7, 8. So if you look closely, for octagon, all sides are equal, right? So S1, S2, S3, S4, they equal. There's no question about that. Let's look at 5, 6, 7, and 8. AB is the side of the octagon, and this one is the side of the octagon as well. So 5 is a right angle triangle, and with the isosceles part, the side, as the side of the octagon. So 5 is actually equal to S1, S2, S3, and S4. If 5 equals to these, 5, 6, 7, 8, they are both equal to each other, right? Because this is just a square divided into 4 equal parts. So this all equal. Now, when they are all equal, and you know the area of the octagon is 40, then you can easily figure out, because all these parts are equal, right? And these parts are equal. So the shaded area is actually 1/2 of the total. So 1/2 of the total is 20. Practice problem 12. For any quadrilateral ABCD, E is the midpoint and F is the midpoint. Find the value of the area triangle AED and the triangle plus area BFC versus the total area ABCD. So in this problem, we only need one additional line to help you visualize. So if you add one line here, we look at triangle AED and DEB and this one. So these two, the base is the same and their vertex is the same point, which is D. If you draw a height to the line AB, this height is going to be the same for this triangle and this triangle, right? So these triangles have the same area. Let's look at this big triangle, BFC and BDF. So for this triangle, this one has the same base, and they also have the same vertex. If you draw a height, which is a vertical line from the opposite side, B, this is the height. The height is the same for this triangle and this triangle. So therefore, these triangles are the same in area. Therefore, area DAE, BFC adding together is 1/2 of ABCD. So the ratio would be 1/2.